Hi, and welcome to The Router, the official podcast of the UQ Computing Society, where we explore the human side of tech. I'm your host, Matt, and we are back after exams with a brand new episode. Today, we're having a chat to Kendrick Tan, also known as @Kendrick on Slack. He has worked in the blockchain space for many years and currently works at DFX in decentralized finance, where he is the chief technical officer. He's here to give us a 20-minute rundown on blockchain, Ethereum, decentralized finance, and more, as well as addressing some of the concerns regarding the past, present, and future of cryptocurrencies. All right, welcome, Kendrick, to the show. How are you today?
I'm good. How are you?
Yeah, I'm all right. Before I begin, it'd be good if you could introduce yourself to anyone who doesn't know about you, who you are, what's your background, where you work, that kind of thing.
Yeah, I'm Kendrick. So I graduated from QT in 2019 with a computer science degree. The reason I got a computer science degree is because my mom wanted me to get a degree, and that was like probably the quickest way to get out of uni. And so I got one.
Mm.
So after graduating, I've been working full time in the cryptocurrency space. I originally wanted to go to get a FANG job, but after dipping my toes in this whole ecosystem, I decided it would be such a pity if I didn't kind of grab the opportunity to go in such an emerging field. Since 2019, I've been working with various companies, one of them being the Ethereum Foundation. So I contracted with the Ethereum Foundation for about half a year, and we did a lot of work on zero knowledge proofs, which is like basically moon math, as people like to call it. But I was the one reading the papers and applying the math rather than coming up with the math. So there's a very big difference in that. It was very fun. Like I learned a lot about the processes of how like these cryptographers came up to these conclusions and how to actually like use them, and how like it's really interesting how you can like use these properties in Ethereum specifically. Anyway, I also worked with a couple of layer two scaling solutions on Ethereum, which is like products or applications or protocols that are dedicated to help make Ethereum scale, so like high TPS or higher transactions per second. But
Mm-hmm.
eventually, during 2020, I found out about DeFi, the decentralized finance, and after dipping my toes into that, I decided like I wanted to go full time into that, and so I worked for a company called UMA. Unfortunately, the time zones didn't work out, and so I left, and now I'm currently working at DFX, which I'm also the CTO of.
Oh, very nice. So you kind of started working in Ethereum more generally, and then moved into decentralized finance. S-
Yeah, yes. So it was
Yeah.
mostly I was interested in the cryptography space.
Mm.
But then suddenly like this wave of innovation came from like on the finance side. And I didn't know anything about finance back then. I was still like a geek, like
Mm.
more like a technical guy, but just the amount of like smart people in the space kind of convinced me that maybe I should check it out. And the minute I did, I was like, there's no turning back yet.
Mm. Yeah, that sounds super fun. I guess to begin, because personally, I don't know too much about this area of work. Could you begin by trying to give like a, I don't know, explain like I'm five kind of introduction to what Ethereum is, how it differs from, Bitcoin or other cryptocurrencies, and maybe also a bit of an intro into what decentralized finance is?
Yeah, yeah.
Yeah.
So Bitcoin at its very core is just a ledger which all the participants in a network will agree upon the state of the ledger. And in Bitcoin's case, it'll be how much Bitcoin everyone owns. So, for example, if there's like 10 participants eventually, and let's say I'm sending you 10 Bitcoins, eventually everyone like it will broadcast a signal telling everyone in the network saying, "Hey, I sent you 10 Bitcoins." And eventually, everyone's ledger will kind of agreed upon that I've sent you 10 Bitcoins. And so they'll deduct 10 Bitcoins from my account and add 10 Bitcoins to your account. So that's like a very at its highest level. There's like more complicated stuff such as P2P networking, routing, and consensus theory. But let's just ignore that and focus on like the core idea, which is like a decentralized ledger, which will form eventual consistency, or like a distributed database, if you want to put it that way.
Okay.
So that's Bitcoin. State A to state B. I want to kind of emphasize that state transition because it's very important. In Bitcoin's case, it's very application specific. It just tells you how many Bitcoins has been transferred from A to B, or like the delta, or like the state of how many Bitcoins you own. Ethereum, on the other hand, can be seen as like a hacker's Bitcoin. So instead of having a very rigid system, a very rigid state transition system from state A to state B, any programmer can create kind of arbitrary logic to kind of indicate how the state transition should be from state A to state B. So if I want to, like, say, deploy a new token on Ethereum, I'll basically create a new token and deploy it onto the ledger. Like there's like a database where it stores like the bytecode of your application. And from, let's say, state A doesn't have the token. State B, once you deploy the contract, state B will state that, hey, in this storage slot, as they like to call it, there's now a new token with this bytecode. And now I can execute arbitrary code against, execute like some kind of code on Ethereum against that deployed bytecode to change more states. So it's more like a generalized state transition machine. And also keep in mind that the Ethereum runs a virtual machine, just like the JVM, but they call it the EVM, Ethereum virtual machine, which is also Turing complete. So now you have like generalized state transitions. So that's like Ethereum in a nutshell. You have Turing complete state machine, and Bitcoin's like more like a application specific one. So in that sense, that's what I like to call it, like a hacker's Bitcoin. It's a lot more exciting because you can build anything you can dream of. Well, right now it's mainly finance because Ethereum and Bitcoin are speculative assets. So like the main applications built on Ethereum right now are financially related, which brings us into DeFi. So DeFi is this movement from kind of like the secret world of Wall Street and like the centrally controlled like sovereign money into this like cyberpunkish like democratized money platform, if you will, which is essentially what DeFi was. I remember 3 years ago when I started out in this space, there wasn't a stable coin when I started out, but now there's like so many financial infrastructure that it's impossible to keep up in the space.
I mean, so there's so many like different words that kind of get thrown around when it comes to like cryptocurrency and this sort of thing. So it's good to hear about a few of those things. Are there any other kind of more specialized things that you work in? Maybe you could give a brief intro into. You mentioned zero knowledge proofs before. What is that like? Like what is it like working in that space? It's a cryptographic thing, right? So I guess is there like a lot of math involved, that kind of thing?
Keep in mind, I was the one who was reading the papers, and I didn't come
That's
up
all
with
good.
the proofs. Yeah. But essentially, what I did, my work in the zero knowledge proof space was it was like a voting system. It's like how do I vote for someone without revealing my vote? And in fact, if you're interested in it, I think EY also released something to do with like transacting on the blockchain with zero knowledge proofs. So how do I create a receipt to a company that I'm dealing, that I have like some kind of relationship to kind of prove that I sent payment without actually revealing the payment? Because keep in mind, these payments are publicly on a public ledger. And if your competitor knows like who you're paying and how much you're paying for what amount of like supply, then it's like kind of bad news because then they can kind of use this information to their advantage. I forgot what it's called, but if you look up EY zero knowledge proof Ethereum, come up. Yeah,
I'll link that in the description of the podcast. If you want to find it. Yeah.
So essentially, it's like how do I prove I have something without necessarily revealing that particular something? Is the whole idea of like zero knowledge proofs. There's also like other rabbit holes that you want to dive deep into as consensus theory, which I haven't touched at all. But there's also something called MEV, or miner extracted value. When when I mentioned like state transitions, the order of state transition can be exploited. It's almost like an order on an exchange, like a high frequency exchange. If you were to suddenly jump the queue, you would like profit the most. And it's the same with like mine and extract value because miners kind of dictate the order of transactions that occur and how do you like game the system. So what order the state transition occurs will yield maximum value is also quite a new field. It's only come around in the last 4 months or 5 months, but it's slowly gaining momentum.
Ah, sounds interesting. I'm yeah, new to all this stuff. I guess another question that people ask, I think, when they hear about Ethereum, cryptocurrencies, and this kind of thing, um, at least from what I've heard, it's kind of some people think of it as something that you kind of treat it like a stock or like a a currency. You're like just buying into it, and you just hope to see the price rise when you buy, and try to make some money off of it.
Yep.
But I guess some people like me are wondering like there are some obvious benefits to decentralization, and I guess getting rid of that mysterious Wall Street hole that the money seems to go into. But like, what other like does it solve any other kind of problems? Like, what other things can you apply this Ethereum idea to in terms of like technology?
That's definitely the main narrative. So Bitcoin as like a decentralized store of value that's like not. To answer your question, sorry, that's one of the main.
Yeah. Okay.
That's one of the main use cases recently because Bitcoin has been like a transfer of value, like a store value that you can electronically transfer. Like Bitcoin is money as a data structure, which that concept is, in my opinion, incredibly powerful. I guess we don't really experience it here, like in Australia, because there's a lot of we have a stable political system. Our currency is relatively strong. There isn't much need to kind of go outside of like sovereign money. But if you live in, say, Zimbabwe or Venezuela or Turkey, more recently Turkey, where there's like a dictatorship happening, and there's like it's political instability, there's a real need to have access these kinds of instruments because you want to be able to leave the country with your wealth intact. Like it'll be, I mean, if you can escape the country but start from zero, that wouldn't be ideal, right? Yeah. But to answer your question, that's like the main use cases, and I can foresee certain other use cases such as voting on blockchain, but that kind of brings up a lot of other potential issues with that scenario.
Yeah, like I guess what's confidentiality and making sure that your votes are secret. I've heard about some approaches to this kind of making elections better, but it seems like the best way forward is to keep developing this technology, seeing if we can get around those issues, and it's better than at least it sounds like there's more potential in these blockchain approaches than the current system of digital voting, which is just some dodgy Windows XP machine in a booth that you just type your votes into and hope that it is correct. And
yeah, because with voting, like how do you guarantee that the hardware you're running is going to execute what it says on the screen? Like we don't even know that. Like there's a lot of issues with that. Like from the hardware level, I mean, even if the software is perfect, how do you can't guarantee stuff on hardware? It's just too many potential backdoors.
I'm gonna pivot over to something a little bit different. So you're talking about, I guess, the use of Bitcoin and cryptocurrency in general. Like it's kind of going up, and I've noticed like there've been news stories about how like in El Salvador and countries like that where they're starting to accept Bitcoin as like legal tender. So Bitcoin is becoming more and more popular, and people are more and more interested in possessing Bitcoin, mining Bitcoin, obtaining Bitcoin. And that's kind of led to this discussion about the environmental impacts of cryptocurrencies, because obviously currencies in general have their own environmental impacts, generated by all this production of, minting and things like that. but it's a bit unique and it's a bit different because now it's kind of intersecting with the tech world a little bit, and where, you know, there's been this rise of people purchasing GPUs to mine Bitcoin, and, you know, different methods of verifying ledgers and things like that have led to the increase of like computational use of power. So I guess there's like a few things been brought up about that. I guess could you give a bit of background from your like cryptocurrency perspective about what are the issues about it? What is the issues of Bitcoin or cryptocurrency, and in terms of that, and how is crypto trying to tackle these issues?
Well, first of all, I completely agree with your statement that it's consuming too much electricity. However, I would like to point out that a lot of the like the criticism surrounding the electricity consumption by the media is a little bit misguided in some sense.
Okay.
This is because like Bitcoin and cryptocurrency mining in general have this very unique property. Like they consume power in a very geographically independent manner. So we're used to consuming power that's kind of close to us. So for example, in Brisbane, we're used to consuming power that's kind of generated in Queensland. It would be absurd to think that we would consume power generated in somewhere like Singapore or somewhere in New Zealand or somewhere in Iceland or China. But that's exactly what Bitcoin's doing. It's actually consuming electricity in areas that are in areas that have an overabundance of power. So, for example, like the main mining hubs in China, in Sichuan, and in Mongolia, was far away from the city center, as well in Iceland. In Iceland, where like the city, like actually cryptocurrency mining consumes more electricity than I think certain parts of Iceland. Like, the point being that like these electricity consumption is actually being consumed. And also keep in mind that energy is really hard. Like electricity in particular is very hard and very expensive to store. So the minute you produce it, it kind of needs to be consumed immediately. Otherwise, it would be wasted. And electricity consumption has to like kind of go with like the peaks and troughs of our consumption. So for example, in the afternoon, we might consume more electricity, but like at nighttime, we might consume less. Whereas Bitcoin's like constant. So I guess what I'm trying to kind of articulate is that a lot of the times, like these energy consumption by cryptocurrency and Bitcoin in particular, Bitcoin mining in particular, would otherwise be electricity that's kind of wasted. So you're kind of monetizing and kind of like a resource that would otherwise go to waste. However, I do agree that it is contributing to a lot of like the greenhouse gases, and there are certain ways, there are plans in Ethereum, not for Bitcoin. Bitcoin kind of staying on this whole proof of work thing where you use like computational resources to kind of validate the block state, whereas Ethereum is kind of moving on to this system of using this system called proof of stake, where you use capital to verify, to validate like the block state, rather than using rather than using a computational power, which would, in theory, significantly reduce the energy consumption.
So I guess there's more approaches being developed now to try to get around this issue. I guess that's good. Do you think that as a result of this, people might move away from Bitcoin, or do you think that Bitcoin is kind of going to have the same role that it has now?
Bitcoin has passed the Lindy test too many times. It's going, like, a lot of times, like these ledgers or like these cryptocurrencies are kind of like a social consensus amongst people. I like to think that. Like there's now a social consensus amongst like all the hedge funds and all like the big finance companies that Bitcoin is here to stay, and they're kind of looking more deeply into it. And so I do not think that, and Bitcoin is the dominant asset that's looked at as a store of value to kind of hedge against the recent supposedly U.S. inflation. So I do not think that people, particularly, I don't really think anyone would really move away purely because of these energy consumption issues.
It's good to keep in mind, the impacts of that kind of thing. And
Oh yeah, I completely
yeah,
agree that it
yeah,
can be better, but
yeah.
if you, I mean, naturally, and also if you think that Bitcoin as a settlement layer is worth $0, then naturally, all it really depends on how much you value Bitcoin as a settlement layer, right? As you
Mm-mm.
mentioned, currencies, the creation and minting of currencies themselves do generate kind of like greenhouse gases and contribute to global warming. So if you think that Bitcoin as the settlement layer is worth $0, then naturally all the energy, like no matter how little energy it consumes, that's too
It's
much.
waste. Yeah, yeah.
Yeah.
All right. I didn't really have any other questions to ask. One thing I wanted to ask is if listener, someone listening would like to find out more about these kinds of technologies, where do you think they should go? Like, do you have any kind of resources, things to read, things to watch? I don't know, recommendations?
Personally, I found that creating a Twitter account and following a key set of thought leaders is probably
Mm.
the best way to get forward because the information just there's just too much information out there. It's too sparse. There's no real uh, there's no centralized repository where you can kind of go through and find out what to do. Like it's just too much happening every day. Like every day, there's like a new concept or like a new protocol being released. There's like a new paper that you should read. And
Yeah.
so I would highly recommend like, creating a Twitter account and following a few key key influences, if you will. That's like how I stay updated. Otherwise, it's just impossible.
Yeah. So it sounds a lot like ML has been for the past few years, where it's just a constant like stream of information, and the only way to keep up is Twitter or like archive, and just it's crazy.
Yeah,
But
yeah, definitely some similarities there.
yeah. All right. That's it for me. Thanks so much for joining us on this episode. I'll make sure to link everything that's been mentioned in the description. And yeah, thanks for coming along.
Thank you. Thanks for having me.
Thanks. All right, that's all we have time for today. Thanks for joining us. As usual, our next episode will be out in a fortnight, but until then, come join us on our Slack community at slack.uqcs.org.